Here's homework help on section 4.3, WebAssign. It's number 3, textbook number 61. And so here we have 60 degrees. We're supposed to find the exact values of x and r. And so there are two ways to do this. So first I'm going to go through the way using sine of 60. And then I'm going to use the special right triangle properties, which is actually really, really nice and short if you remember those properties. So 60 degrees, we have 35, which is opposite, and then we also have hypotenuse. And so looking at this, we can use sine of 60 degrees equals 35 over the hypotenuse of r. So what we can do to solve for r, we can multiply both sides by r. And then, so this is r sine of 60 degrees equals 35, then divide by sine of 60 degrees. Now, sine of 60 degrees, or pi over 3, we know is the y value. And thinking about 60 degrees, or pi over 3 is here. I know that my value is 1/2 and square root of 3 over 2. So then, if I just plug in the y value, right, because that is what sine of 60 is. Sine of 60 is square root of 3 over 2, so I put square root of 3 over 2 here. And then, so we can simplify 35 times 2 over square root of 3, and so we get 70 over square root of 3. And that's how it wants, the exact number. So the hypotenuse is 7 over square root of 3. Then to find tangent, so we're going to use tangent. We're going to use tangent of 60 degrees because we have opposite over adjacent. So tangent of 60 degrees is 35 over x. Tangent of 60 is going to be this y over x. So just to kind of do the work a little bit, square root of 3 over 2 over 1/2. So that's square root of 3 over 2 times 2 over 1. That's just square root of 3. So therefore, we find that tangent of 60 degrees is 35 over square root of 3, and that is our x value. Okay, so that's one way to do it. Now, another way to do it is that there's a special property with right triangles, 30, 60, 90. Let me draw this a little nicer here. So 60 degrees, and then this is 30 degrees. And so there's a special property with this that maybe you remember from geometry. So this leg here is x. Okay, the shortest leg is x. To get to the hypotenuse, it's 2 times x, and this is square root of 3. So if I use that property instead, right, of the special right triangle, 60 degrees here, 30 degrees is here, they give me the long leg of 35. Now to get from the long leg, oh, that should be x square root of 3, I apologize. In order to get from the long leg to the short leg, so x root 3 and x, notice what they did is they divided by square root of 3. So to get from the long leg to the short leg, you just divide that by square root of 3. So it's 35 over square root of 3. Then in order to get, so looking at the original, in order to get from x to 2x, you just multiply by 2. So you multiply 2 times 35 over root 3. So 2 times 35 over square root of 3, you would have 70 over square root of 3. Okay, so that's the short way to do that problem. You could do the same thing with the 45, 45, 90-degree triangle. So with this, we know if this is 45 degrees here on this side, we also know that this is 45 degrees, and we know that this is an isosceles triangle, so it's 28. Now to get to the long leg, so if you know the special right triangle, 45, 45 degree, one leg is x, this is x. To get to the long leg, it should be longer, so it's x square root of 2. So in this case, the r is 28 square root of 2. Now again, the other way to do it was just using the 45. We could do opposite over hypotenuse, so sine of 45 degrees, so opposite. So this is opposite over hypotenuse. So opposite is 28 over the radius r. So 28 over r. So to keep on going, so sine of 45, let's just change that to root 2 over 2 here. So that's another way to do it. And 28 over r. And then so we're just trying to find r. So let's multiply by r to both sides. We get r root 2 over 2 equals 28. And then to get rid of that 2 root 2, let's multiply by the reciprocal to both sides. Okay, so that cancels out. So therefore we have r equals 28 times 2 over square root of 2. So this is 56 over root 2. Now let's rationalize the denominator because I want you to see that we get the answer that it says. We have 56 root 2 over 2. Then 2 divided by 56 is 28 root 2, right? So that was a really long way to do this problem. And so using special right triangles makes it so much faster and shorter. If you would just remember these properties here, the 45, 45, 90-degree triangle. So again, to talk about that, to get from, one of these legs to the long leg, it needs to be longer, so you multiply. If you're coming from the hypotenuse to one of the legs, and you need to divide by square root of 2, right? You need to make it smaller, divide it. For 30, 60, 90, you just have to remember the short leg is x, the hypotenuse is 2x. Then to get to the long leg, it's x times root 3, right? You want to make the short leg longer. Then if you go from the long leg to the short leg, you have to divide by square root of 3, right? X, if this was like 10, you divide by root 3 to get here. So that's how you have, the x here, x root 3 here, and just an x here. And then you multiply by 2 to this short leg to get to the hypotenuse. So hopefully this helps a little more. Now you could certainly use our trig ratios, tangent of 60, sine of 45, and so forth in order to solve it. But you are also allowed to use the special right triangles as well.